Welcome to class number 7. We're going to be talking about concrete, one of my favorite materials to work with. Concrete is remarkable. It's flexible. You can pour it into a form of any shape, any size. It will conform to that shape and produce a very interesting looking end result. You really should take advantage of that property of concrete and look for creative, attractive shapes instead of the typical square, vertical-sided boxes that we see too much of. It's easy and inexpensive to give the concrete an appearance that we will all admire for the long life of the project. And you can also take advantage of the natural patterns of the formwork and the tie holes and integrate them into your design so that they're not just a random pattern, but they actually serve to improve the look of the end product. And you can create grooves and all kinds of fenestrations to improve the look of the finished product. My own personal preference is to stay with the finished look of the concrete and not try to introduce some kind of artificial pattern, use a foam liner which imparts some artificial appearance to the surface. For my part, the concrete is very handsome as it's cast, and I'd rather have real concrete than fake looking anything. Bottom line, give the appearance a great deal of thought because people will be looking at these structures for a very long time. What is concrete? I'm using this graphic because it has a very interesting look, and also because it lists as the first ingredient air. I think most people, if you ask them to list the ingredients in concrete, they would not include air. But it turns out air is very important. It leads to a much more durable product, and it is in fact an essential ingredient. It usually occurs naturally when you mix concrete, but you can also use an additive which will ensure that you get the amount of entrained air that you're looking for. Now, while I enjoy the look of this graphic, I would be very cautious about the percentages of the various ingredients. I'm not sure I agree with that at all. They show 16% water. I think that would be a very weak mix, and I believe a good mix requires much less water than that. Nevertheless, this graphic comes from the Portland Cement Association, a very well-respected body of people, and it is a nice representation of what is contained inside the concrete. Now, what I learned as a tool early on was a ratio of 1 to 2 to 3.5. It served me well whenever I had to mix a little the concrete in the backyard for a fence post. It would be 1 shovelful of cement, 2 shovelfuls of a fine aggregate, usually sand, and 3 shovelfuls of a coarse aggregate. Could be some kind of gravel or broken stone. That produces a very good result. And if you want to have a little clue in the back of your head of the proportions, 1 to 2 to 3.5 I think would serve you well. Now, after you combine the dry ingredients, you add only enough water to make the mix workable. The addition of more water will make it easier to work with, and that's why people add more water, but it radically reduces the strength of the final concrete. So you need to exercise self-control and limit the amount of water that you add only sufficient to make the mix workable. Now, of course, in this day and age, if you needed a little concrete for the backyard, you'd buy a bag already mixed in Home Depot. But when you get home, again, add only enough water to make it workable. Here's a chart that shows the effect of adding water to concrete. The blue curve begins with the highest strength and falls off dramatically as you add water. Adding water is something that you must control. And if you add too much water, you've sacrificed the strength of the concrete, and there's no undoing that. Once the water is in there, you're going to use that concrete and get poorer results. Now, of course, if you overdo it, you really should reject that concrete truck and send it away. But in the real world, this rarely happens. You need to begin by carefully controlling the amount of water that goes in. Now, you really don't have to carry around in your head the ratios 1 to 2 to 3.5 and how much water. This is all figured out in advance in a laboratory. For each project, you need a lab to sample the actual materials that will be used on your project and produce a design mix, including recommendations for how much water needs to be used. And chances are they will produce more than one mix. The mix used in a footing is probably a lower strength mix than a mix used in a wall, and in a concrete bridge deck, the concrete mix may have slightly different proportions. And for special applications, like when you're pumping concrete, that requires a different ratio of components. So this all needs to be done in a lab ahead of time, and it's a very good idea to get that process going promptly so that the day that you actually need the concrete, all of that paperwork is already in place. You can use additives to the concrete to affect the performance in several different ways. You can accelerate the rate that the concrete sets and hardens, and that is usually called high early concrete. Typically that's used when you're placing some pavement and you want to place that in service as early as possible so that you can shift traffic and move into the next phase of construction. You can add retarding agents which have the opposite effect and will slow down that initial setting of the concrete. You may need to do that in the middle of the summer with the wind blowing if you're trying to finish a concrete deck surface. You may find it's setting up faster than you can actually control the finishing process. So you can slow that process down. Air entraining, I mentioned briefly. You can control the amount of air by introducing additives. There may be enough air resulting from the natural materials that you're using, but you may also want to introduce an air entraining agent. Water reducing is an important additive. You need to limit the amount of water and use a mix that's relatively stiff. That will produce the highest strength concrete. But there are situations where that could be unworkable. And in my experience, typically in a precast concrete yard, they have a rebar that's closely spaced, and there are post-tensioning conduits, or there could be post-tensioning strand. It's a very dense matrix of material inside the forms, and you need to ensure that the concrete moves around these rebars and fills every possible void. Now, to do that, you may want to introduce a water reducing agent, which is called a plasticizer. That means you can still use small amounts of water but get a much more fluid plastic mix. So that's an excellent solution. Slump Test is a very important tool in controlling the amount of water that you add at the job site. You really can't look at concrete by eye. Even after years of doing it, it's a very poor gauge of whether or not there's enough water, whether or not it's workable enough. So a slump test is used, the sample is taken, and you make a controlled measurement of the workability of the concrete. And I have a video showing that process.